Hi, we have two DNA strings and we are to find out how many of the characters, the DNA bases, are different between them and the same length. So this is easy. Here's a sample, and if you want to see which ones are the same, then we can get the mask like this. And if you want to know which ones are different, then we can do an unequal. And then we all just need to know how many ones are they here, but because true and false in APL are represented by 1 and 0, and since they are just numbers, they're not separate type, we can just sum them. And summing them is using plus reduction. So we're reducing the result of this because every function, including this derived summing function, has long right scope. So we take everything on the right as argument. So the result of this, which is the mask, gets summed, and that gives us the number of differences. This isn't a single function. We could wrap this up a little bit as a function, so we can uh, call the left argument alpha because that's the leftmost character in the Greek alphabet, and the right argument is called omega. And then we can put braces around it to mark it as a lambda, and then we can give it a name, or we could call it directly in line. So now we can go up here and apply our function to get the same result. We can actually be much shorter than this, even though this doesn't look like much. And that is because we can switch to tacit mode. The way we do that is tacit means we don't mention the arguments. And if you just remove the arguments and also the braces, and let's give it a new name, then we can do it like that. That works too. However, this definition we cannot put inline as is. If we wanted to do that, then we would have to parenthesize it like this. There is, however, a tacit inline definition that you could put inside, and that is as an inner product. So inner product, let's try that first. So if we say 1, 2, 3, so we have two vectors, or they could be scalars. It could also be higher rank arrays, but that's not what we're dealing with here. And for up to one dimension, then the inner product is the same thing as a reduce over the result of a scalar operation, also known as a map reduce. At least kind of, because it takes two arguments. So let's take 10, 100, 1000. And the inner product simply pairs up elements with the corresponding element over here. So this is 1 times 10 plus 2 times 100 plus 3 times 1000. And therefore, we can just replace the multiplication with the unequal, and the plus stays the same, and that would still work. So if we could do that here, we'd simply replace the slash with a dot, and that gives us this. And this, because this is a dyadic operator, it combines these two functions to a new function, and this is constitutes a single function, whereas this before was two adjacent functions. The plus slash is one function derived from this monetic operator, higher order function, that makes the reduction, and the unequal, which is its own function. So we have two functions. Here we just have a single derived function, and so we don't actually need the parenthesis like that. So we can call it that as well. And then we can go up and apply it here if you want to do that. Thank you for watching.